Students, we are going to venture into the world of constructions. It's very important that you have a compass and a straight edge. And your compass, if your compass has a little screw, a screw or screws at the top, it's important that they are very tight. So go to the front of the classroom and get a Phillips screwdriver and tighten that up a little bit. You want your compass to be relatively stiff when you do this. If you have one of these types of compasses, you don't need to worry about stiffness. And then you're going to need a straight edge of some sort, okay? Not a piece of paper, an actual hard straight edge. You need to respect these tools. A compass and a straight edge of some variation has been used for thousands of years to draw extremely accurate and precise diagrams long before the invention of any kind of ruler or tape measure or protractor. We're going to be doing 4 constructions, basic stroke constructions, and then 4 triangle centers. So the first one is a midpoint, a perpendicular from a point, a perpendicular bisector, and an angle bisector. The midpoint, the steps to find a midpoint is sweep, sweep, point. Sweep, sweep, point. Let me show you what I mean. I'm going to do it working both right-handed and showing you using this compass. And I'm going to show you what's also the tilt and twirl. Very important. When you use a compass, you never hold it straight up and down, and you never hold it with both hands. You're going to be twirling. You tilt and twirl from the pivot point, or tilt and twirl and drag from this top holder. Never grab with 2 hands. Okay, so a midpoint looks like this. You want to open up your compass setting so it's just past what looks like the middle. Just past. Then you sweep a large arc. Okay, sweep a large arc. Then come around the other side. Do not change your compass settings between the sweeps. Put it on this other pivot and sweep a large arc. Sweep, sweep, point. We have 2 points of intersection. Line them up with your straight edge. Do a little tick mark, and that is an exact midpoint. All right, using another technique, I called this the tilt and twirl method. Let me get my compass settings exactly the same here. All right, instead of twirling the compass, I hold at the pivot and I twirl my paper. You can do that as well. Tilt and sweep. Go to the other side, plant your pivot. Tilt and sweep your paper. So it's sweep, sweep, point. Line those up. Get your exact midpoint. And because it's a midpoint, you must add hatch marks. That's a midpoint. Now we're going to do a perpendicular from an exterior point. And the steps for this one are smiley, dimple, dimple. Smiley, dimple, dimple. Smiley, dimple, dimple. Let me show you what I mean. Step number 1, you want to open up your compass, put your pivot on this external point. Open up the compass just past the line, straight across. And you are going to tilt and tilt from this pivot, and you're going to sweep a smiley. Smiley, And what I call dimples are these 2 points of intersection right here. See, kind of a smiley with a dimple. Do not change your compass setting between the dimples. You plant it on one dimple, sweep, plant it on the other dimple, sweep. You're going to line up that P with this exterior point of intersection way out here. And you now have a perfect right angle, perpendicular line coming from a particular point. Now I'll do it again using the twirling of the paper method. Okay. I'm going to open up the compass setting so it's just past the line. And I'm going to plant that pivot. And instead of twirling my compass, I'm just going to tilt my compass and I'm going to twirl the paper instead. Smiley, smiley. Then you come to one point of intersection, twirl the paper, dimple. Other point of intersection, dimple. Smiley, dimple, dimple. Line it up to that point of intersection out here. Once again, you have a perfect right angle coming from an exterior point. Smiley, dimple, dimple. Our third basic stroke construction is a perpendicular bisector. You do sweep, sweep, make a segment. Sweep, sweep, make a segment. It's actually the same one as midpoint, except instead of drawing a point, you're going to make a segment. You put your compass on the end point, open up just past what looks like the middle. And you're going to do a sweeping arc on both sides. So sweep, plant, tilt, sweep. Line up your points of intersection. Remember, perpendicular means make a right angle. Bisector means go through the middle. So not only do you have a right angle, but you have an exact midpoint. So this segment is a perpendicular bisector. Using the other method, the paper twirl method, I'm going to plant, and instead of dragging my compass, I'm going to twirl the paper, and I'm going to go sweep, keep the same compass setting, go to the other side. Sweep, line this up, right angle, hatch mark for a midpoint. That is a perpendicular bisector. Last one is an angle bisector. It's also smiley, dimple, dimple. Smiley, dimple, dimple. Let me show you what I mean. It doesn't matter how far your compass setting opens. What does matter is whatever angle you just open it up so it's somewhere between the arms of the angle. In other words, I'm not going to go way out here. I could go as small as this. I can go right to the edge if I want. I tend to just kind of go through the middle-ish. And an angle bisector is you plant your pivot and you sweep a smiley. Smiley. You have 2 points of intersection. I call those dimples. You don't change your compass setting between them. Put one here. Dimple, sweep. Dimple, sweep. Smiley, dimple, dimple. You're going to have a point of intersection. Line that up. And you now have yourself a perfect angle bisector. I'm going to do that again using the paper twirl method. All right, so this time I'm going to twirl the paper instead. I'm going to plant and drag my compass, tilting, smiley. And you go to the point of intersection. I call that a dimple. And again, drag your paper, dimple. Here, drag your paper, dimple. And where that intersects, that is going to be angle bisector. And as it's a bisector. Now, those are your 4 basic strokes. Once again, a midpoint, a perpendicular from an exterior point, perpendicular bisector, and an angle bisector. Now, using those 4 strokes, we are going to do the 4 interior centers. There's 4 different types of center for a triangle. And those 4 centers are a centroid, an orthocenter, a circumcenter, and an incenter. We're going to be constructing all 4 of them. And they are based on the 4 triangle guts. And the 4 triangle guts are a median, altitude, a perpendicular bisector, and an angle bisector. This was in the preview notes. The intersection of the medians is the centroid. The intersection of the altitudes is the orthocenter. The intersection of the perpendicular bisectors is the circumcenter. And the intersection of the angle bisectors are the incenter. I remember this by saying MAPA and SOSI. MAPA and SOSI matches together. We're going to do a centroid first. A median connects a median connects a triangle vertex, which means corner, to the opposite midpoint. And remember, our midpoint construction is like this one. It matches this: sweep, sweep, point. Sweep, sweep, point. That's what we're going to be doing. A centroid is the intersection of the medians. So it says we're going to construct a midpoint of PQ and label it S and draw in the median RS. So we're going to construct the midpoint of PQ. PQ right here. And we're going to label that midpoint S. So the midpoint, you're going to put your pivot here at the end, go past just what looks like the middle. And you're going to do a sweep. Sweep. Line this up, these 2 points of intersection. Do that tick mark. And that tick mark is going to be point S. And it's a hatch mark. And we're going to draw in the median RS. So the median RS goes from R to S That's a median. I'm going to show you the paper twirl method. All right, so I'm going to plant and twirl the paper, make a sweep. And I'm going to come over here, plant, twirl the paper, sweep. Going to line up these points of intersection. Put a dot there. That's our median S. And I'm going to draw in a median RS. So we're done with that one. Now I'm going to construct the midpoint of PR. So here's PR. I'm going to label that midpoint T, and I'm going to draw in the median Q to T. You're going to put your pivot on one of the endpoints, R. I'm opening up just past what looks like the middle. Remember, it's sweep, sweep, point. So sweep an arc. Don't change your compass settings. Sweep an arc. Line up your points of intersection. You're not drawing a segment, you're only drawing a point. That's why it's sweep, sweep, point. That point is going to be T. It is our second midpoint. And then we draw in Q to T. That's our second median. I'm going to show the other method where we twirl the paper instead. So pivot, sweep, plant, sweep, line up your points of intersection. There's our midpoint. And so we got two medians. The medians intersect at the centroid D. So we're going to call this D. From here, I give you some information. It says, remember, with the centroid, there is a 1 bunny hop and 2 bunny hop relationship. Draw that both ways. 1 bunny hop, 2 bunny hop relationship. It's a 1-to-2 ratio, those segments. So it says if SD is 8, find the length of SR. This is 8, 1 bunny hop, 2 bunny hops, find SR. Pause the video if you need to. Okay. Second one says if QT is 27, so I'm going to put my fingers like this. If this whole thing is 27, from here all the way to here is 27, find the length of QD only. Well, look carefully. 1 bunny hop, 2 bunny hops. Put your fingers like this at 27. Knowing those bunny hops are equal, ask yourself, what would this be and what would this be? Pause the video. All right, now we're doing an altitude. An altitude connects a triangle vertex to a right angle on the opposite side. A right angle on the opposite side. So vertex, right angle. It is also a smiley, dimple, dimple construction. The orthocenter is the intersection of triangle altitudes. So we're going to construct 2 altitudes. First, we're going to construct an altitude from point B to side AC. So from this point, going to this side, we're going to create a perpendicular segment. This is a smiley, dimple, dimple. So step one is to plant your pivot at B and open up your compass so it's just slightly past, and I mean slightly past, the opposite segment. Watch. And then you're going to sweep a smiley. When you do this, you're going to have 2 points of intersection. Now, if I don't change my compass settings, you can see I'm flying off the page here. So at this point, if you need to, you can choke up your compass or make it smaller. But from one dimple to the other dimple, do not change your compass settings. So from this dimple, sweep. Don't change your compass settings between dimples. Sweep. And you are going to get an intersection, straight edge. And you have a perfect right angle. Perpendicular. It's not a bisector, it's just a perpendicular. Now I'm going to use the other method where you sweep with the paper. Again, your compass setting is just a hair past, and you're going to sweep a smiley, like so. Smiley. Again, my smiley is flying off the paper, so you choke it up if you need to. I'm going to tilt, drag, sweep. Don't change your compass setting from the other side. Tilt, drag, twirling the paper. And line that intersection up with your vertex. This is an altitude. And the point of intersection is going to be J. So we have an altitude B to J. Next, we're going to construct an altitude from point C to side AB. Label that intersection K, drawing the altitude CK. So for this one, smiley, dimple, dimple. Your pivot's at C. Go just slight hair past the opposite side. And then it is a smiley. You have 2 points of intersection. Tilt, drag. Dimple. Dimple. Smiley, dimple, dimple. From here to that point of intersection, right out here. That is a perfect perpendicular, which makes this an altitude. I'm going to do that again using the paper twirl method. Open up your compass just a hair past. Okay, I'm going to tilt. I'm going to twirl the paper, twirl a smiley. Go to your point of intersection, dimple, tilt, twirl the paper, dimple, dimple. And you're going to line up. Slipped a little bit, it looks like. Should be the same. That's going to be another altitude. at a right angle, and it says we want to call that point of intersection K, labeling the altitude C to K, label the orthocenter R. Now, after completing those instructions, I give you 3 angle measures. The angle measure BAC. Here's B, here's A, here's C. BAC is going to be 40 degrees. Measure of ACB. ACB, this big triangle. ACB, this whole angle is going to be 60. And the measure of angle CBA, which is this whole angle here, is going to be 80. You want to find all possible angles. It also wants you to trace the quad AJRK. AJRK. Keep in mind that quadrilaterals, triangles add up to 180, quadrilaterals add up to 360. So AJRK, whatever you get for this, has to add up to 360 degrees. There's a right angle here. So it says find all possible angles. Let me just kind of point out a good way to start this is take a close look here. This right here, see this? Trace it. Triangle BJC will follow BJC. See that triangle? Do it again. Right here, this triangle is 90. This right here is 60. Let me pull this out so you can see it a little bit better. BJC, this is 90 degrees, 60. Ready? Squiggle, squiggle, squiggle. Squiggle, squiggle, squiggle. You can add 90 plus 60. Take it away from 180. And we get this brown squiggle to be 30 degrees. That's going to start you off. Finger trace. Feel that? If this is 80, and that's 30, that gives you this angle right here as 50. Now you just keep looking for a bunch of different right triangles. There's lots of them here. And find all angles possible. All right, this is my personal favorite. You'll see why in just a moment. A perpendicular bisector is a segment which is perpendicular to a side and bisects a side. It's both perpendicular and bisects. The construction is sweep, sweep, segment. Sweep, sweep, segment. It's the same construction as this one here on page 7. Sweep, sweep, segment. So we're going to construct what's called the circumcenter. Circum means to go around. When Magellan or his crew circumnavigated the globe, that means they navigated around the globe. It's going to be the intersection of perpendicular bisectors. So we're going to construct a perpendicular bisector of PQ and label the midpoint S. Put your pivot on an endpoint. You want to be as accurate as possible here. There's a really good reason why. Something really cool happens when it is. And you want to go just past what looks like the middle of the segment. And it's sweep. Sweep. So line up that point of intersection. Get all the way across. That's a perpendicular bisector. Makes a right angle and bisects. And we're going to label that S. And show you using the other method where you twirl the paper. Plant, tilt, sweep the paper, go to the other side, sweep, line that up, all the way across, right angle, hatch mark, S. Now we're going to construct a perpendicular bisector of P to R and label the midpoint T. Pivot just past what looks like the middle. Sweep, sweep segment. Sweep. Go to the other side. Sweep. You're going to start getting some overlapping arcs there, so just be careful that your eyeballs catch the right intersection. Draw your perpendicular bisector all the way across. Right angle. Midpoint. That's going to be T. The other method, twirling the paper. Plant. And we're going to sweep by twirling the paper. Other side, plant. Twirl the paper. And you line that up. Those points of intersection. And there's your T. Says label the circumcenter U. So circumcenter is where those perpendicular bisectors intersect. And so we're going to call that U. Here comes the fun part. Super fun part. And if you did this correctly, you get boasting points. And sometimes not even I as the teacher, because I'm doing this fast, am paying attention to accuracy. So I might not even be spot on. You might even be better than me, accuracy right now. And if you are, you get to do some sort of little happy dance. Okay? You want to put your pivot on U and open up your compass so that it goes through exactly one corner. So it says corner P. Now, kind of hold your pivot there, and actually twirling the paper works the best here. Okay, tilt and twirl a full circle. Ready? Here we go. Whee! All the way around, all the way, all the way, all the way. Oh, I just missed it. There we go. Now, check your corners. If you are 100% accurate, this is why this is called the circumcenter. It is the center of the triangle that allows you to draw a circle around the triangle intersecting all three corners spot on. So I have one corner correct. My Q is correct. You can see my R's just a little bit off. That happens if your compass slips a little or you're not exactly accurate in your intersections. I might have been a little hair off here. But if you are spot on accurate, your circle is going to go right through all three corners. And if you do, you should do some sort of little golf clap for yourself or some sort of celebratory woohoo something, because that's cool. And our last one. Let's just recap this really quick. Mappa, SOSI. The medians intersect at the centroid. The altitudes intersect at the orthocenter. The perpendicular bisectors intersect at the circumcenter, and the angle bisectors intersect at the incenter. This is the last one we're doing. An angle bisector cuts the triangle corner angles in half. It is also a smiley dimple dimple. The incenter is the intersection of the angle bisectors. We are going to construct an angle bisector of angle QPR. QPR. Let's trace and sweep. QPR. We're going to bisect that angle. Smiley, dimple, dimple. Smiley, dimple, dimple. With the other one as well. I'm going to twirl the paper this time. Pivot here. You sweep a smiley. Smiley. Go up to the point of intersection and dimple. Other point of intersection, dimple. Smiley, dimple, dimple. You line up the dimple arcs, if you will. And you're going to take it all the way through the far side. It's very important you understand this. This is not a midpoint. Okay, your eyeballs are not focused on the segment. It's focused on the angle. So what we just did is we bisected that angle. Now we're going to do an angle bisector of QRP. So QRP, sweep. Oh, you never erase compass markings. Smiley, dimple, dimple. That's that method. This time I'm going to twirl the paper. So you go smiley. Whoops, I was supposed to twirl the paper. Here. Tilt, smiley. Intersection. Dimple. Dimple. Yeah, this point of intersection right here. R. Take it to the far side. Bisecting this angle. Label the intersection I, because it's going to be called the in-center. Okay, now something fun also happens here. It's an in-center for a reason. Says you're going to place your compass point on I and the drawing pencil at PQ. So here, but you want it to be at a right angle. So you're kind of visualizing this. All right, you're visualizing this from here to here being at a right angle. So that's the distance you want. Okay, you're supposed to be kind of visualizing it at a right angle. Open up your compass setting. And now hold. And it's easier to spin the paper here. It looks like I'm a little accurate on this one. Oh, I am. I am right on the money. Yes. All right. There's a reason why it's called an inner center, folks. It is the in center because it is the center of the circle that you can draw inside a circle. And this time I was spot on. If you've done this right, it's going to intersect all three sides just at a point and not go over. So now we have inscribed a circle inside a triangle using the in center. Now, you got a couple things to figure out. We are given the measure of QPR, this angle is 40 degrees. And we are given the measure of QRP, this angle is 80 degrees. And then you have a third measure angle RQP, RQP. This angle is 60 degrees. Knowing this, find all possible angles. Remember, the key to this is that these are bisectors. So right off the bat, you know this is 20 and 20. You're just going to be working a bunch of different triangles, overlapping triangles. See my fingers? I just did several of them very quickly. And find all possible angles in your diagram.